This video is going to be question 13 on your solubility notes. So it's percent concentration by mass. So you kind of know concentrated versus dilute. If we look at these two solutions, they're both copper sulfate. You can tell that this one is more concentrated just by looking at it. It's got a darker color to it. It's more concentrated. You can tell your Kool-Aid is more concentrated by tasting it. You taste it. You can tell if you need to add more sugar or add more water to dilute it down. So concentrated means there's lots of solute dissolved. Dilute means there's not very much dissolved. All right. So if we want to know percent mass of a solute, that's one way to find concentration. We'll do two different ways, this and molarity. We need the mass of the solute in grams, so the stuff dissolved, like the sugar or the salt or whatever stuff is dissolved, divided by the total mass of the solution. So that would usually be the solute plus water. So letter A here. What's the percent mass of sodium bicarbonate in a solution that has 20 grams of sodium bicarbonate and 600 milliliters of water? So our percent of sodium bicarbonate is going to be the grams of sodium bicarbonate over the total grams of solution, meaning the sodium bicarbonate plus water. Now it tells you have 20 grams of sodium bicarbonate. And then the total grams, you have 600 milliliters of water, which is 600 grams of water. So 600 milliliters of H2O, because every milliliter of water is a gram, that means you have 600 grams of water. So don't divide by 600, but the total, 620 grams total. Then multiply by 100, so 20 divided by 620, pretty small percentage here. It's only a 3.2% solution. So that means that 3.2% of the mass is the sodium bicarbonate. The other 96.8% is water. Letter B there. You have 1,500 grams of a bleach solution. That means of bleach and water together. Okay, it's a bleach solution, so you have both those together. And that tells you the percent mass is 3.62%. And how many grams are in the solution. So a lot of times when it gives me a percent, I will say, I'll put the percent out front, so 3.62 over 100, or 0.0362 if you want to do it that way. So our percent is 3.62% out of 100. That means there's that many grams of bleach per 100 grams of solution. So I can say, what is my mass of solute? And it's asking for that. It wants to know the grams of the bleach or the grams of the sodium hypochlorite, which is NaOCl. That's the grams of that out of the total grams of bleach solution, which is 1,500. So it's saying you have 1,500 grams of bleach. How many of those grams are actual sodium hypochlorite, which is the main ingredient in bleach, and then it's mixed with water. So we're looking for that. Cross multiplied by 1,500 times 3.62 divided by 100. That'll tell you how many grams are in there. So we're really figuring out what is 3.6% of that number. And our grams of that are 54.3 grams of sodium hypochlorite. Letter C there. So letter C is saying, in order for an aquarium to be similar to ocean water, you need 3.6 grams of salt per 100 grams of water. So what's the percent of salt? So our percent of salt, well, it says you need 3.6 grams of salt per 100 grams of water. But I want to divide by 100 now. I always want to divide by the total. So it's 100 grams of water plus the 3.6 grams of salt would be 103.6 grams of the total solution. And then times 100 to get it into a percent. So my percent there is about 3.47%, which is pretty close to what the ocean actually is for salt. Letter D, again, it's giving me a percent, so I'm going to say that's 30 out of 100, which means I have 30 grams of salt per 100 grams of solution, or 30 grams of salt with 70 grams of water. It wants to know what mass of solution. So it's asking me for grams of solution, so that's going to be the bottom. Again, the bottom is the solution. If I want to get 4 grams of salt. So I'm trying to get 4 grams of salt out of what solution do I need to have to get 4 grams of salt. So again, cross multiply. This time I want to go this direction. 100 times 4 divided by 30. In that case, it's about 13.3 grams of salt water. Okay, move salt water together. Last question on here. It's a little different question, but it's just saying the potassium chloride solution has 50 grams of KCl03 in a liter of solution. How many grams would be in 100 milliliters? It's just low proportion. So I'm going to say there's 50 grams of KClO3. It's not actually asking me for percent. If there's that many grams of KClO3 in a liter of solution, a liter is the same thing as 1,000 milliliters. It wants to know how many grams, so it'd be X number of grams in 100 milliliters. So if there's that many grams in that, then there's X number in that. If the concentration is staying the same, again, cross multiply, divide, and you get 5 grams.